Hello class, welcome to our lesson today dealing with section 10.7. By now we've talked about things like mean, median, mode, and range. We've also discussed things like the mean absolute deviation, denoted MAD, and the interquartile range, denoted IQR. We're going to start to use those things to help answer some questions as we look through today's lesson with comparing populations. Before we get to that, just a few example questions dealing with solving equations. The first question has multiple x's on the left side, so you have to combine like terms. So 5x minus 8x would be negative 3x. Negative 3x plus 3 equals 23. From there, it's just a two-step equation. Subtract 3 on both sides. Probably the important thing here on this question, though, is that when you divide by negative 3, don't forget that it's just 20 divided by negative 3. That's negative 20 thirds, or negative 6 and 2 thirds. So when you're dealing with that situation, you could leave that as a mixed number then as opposed to a decimal. It could be 6.6 repeating, but you could also leave that as a decimal or a fraction. The second one you could distribute, so you could take the negative 4 and multiply it into both of these pieces inside the quantity or the parentheses. I might suggest dividing by negative 4 right away just to get rid of it, and it actually divides very nicely with the information on the right side. From there, it's just a two-step equation. Subtract 9 on both sides. Remember, negative 5 minus 9 is negative 14 because they're on the same side of the negative realm. And so they just add together and become negative 14. Then you divide by the 2 and you get x equals negative 7 as your final answer. Okay, rather than going through kind of all of this example in its entirety, I went ahead and found the information here, the mean, median, mode, and range, the IQR and the MAD for both the male in the 8th grade, male students in the 8th grade, and the male students in the 6th grade. So I went ahead and went through all the list and found all those information. Now this is shoe size. So this is the size of kids in the 8th grade and kids in the 6th grade. And then we'll use that to help compare some things about this information. If it was a homework question, you may have to find all these pieces. So you have to order the numbers for the median, for example, find the IQR. But for the sake of time, I went ahead and found all those pieces for this example. Next, I created what's known as their box plots. So the box plot, remember, is the 5-number summary in visual format. So that's the lowest number, Q1, the median, Q3, and the highest number. So each of these dots represent that. So for 6th grade, the lowest value is 4. Q1 was 5.5. First, the median is 6. 7 is the 3rd quartile, and then 8.5. Similarly, it's 6, 7.5, 8, 9, and 11. What you want to show here is how the information varies or not. So if you look, let's look at the boxes first. Their interquartile ranges appear to be about the same. These distances from here to here, from the left side to the right side of each of these rectangles, is about the same. That makes sense because their interquartile ranges are the same. So these two situations vary in the same way. The difference here is that the box for this 6th grade one is completely below the box for the second one. We're not looking at these whiskers because those could be outliers or things that, like, one person has a really big shoe size or really small shoe size, could affect those portions of the box plot. But they have the same variation, but do the data sets overlap and the answer is no. And what that probably tells us is that the mean and median of the males in the 8th grade have larger shoes than the 6th grade, which makes sense because probably from 6th grade to 8th grade you've grown. However, they vary similarly, so there's some kids that have smaller or larger feet in a similar fashion in the 6th grade as they do in the 8th grade. This box and whisker plot also shows the shoe sizes of members of the two girls' basketball teams. So first off, if we just find the median and IQR, so for the Tigers, the median appears to be 9.5. The IQR would be Q3 minus Q1, so 10.5 minus 9 would be 1.5. For the Bobcats, the median is 7, but the IQR would be 8 minus 7, which is 1. Can you conclude at least one girl from each team has the exact same shoe size? Now, the answer to that question is actually no. Even though there's some overlap to these pieces of the graph, and you say, oh, there's a dot for both of them. Look, there's a 9, a dot here, and a dot here. While it is true that the Bobcats have someone that has size 9 shoe, the Tigers doesn't necessarily have to have someone with a size 9 shoe because remember that the quartiles, like the median, could have been the average of two numbers. So, for example, this could have been the average between 8 and 10, and it becomes this 9. So you can't conclude that everyone has at least one of the same shoe size, but we can conclude that at least one girl from the Bobcats has a larger shoe than one girl from the Tigers, because the highest value for the Bobcats is 9, and the lowest value for the Tigers is 8.5, which says that someone on the Bobcats has a shoe size higher than the Tigers. The situation here is not only are they significantly different, there's a little bit more variation of the Tigers than the Bobcats, but clearly the Tigers have larger shoe sizes on a whole compared to the Bobcats, which probably corresponds to the Bobcats team being a younger team and the Tigers team being an older team. When you're comparing distributions, things that you want to notice is the median and the IQR when it comes to box plots. So this is male and female students about hours of sleep. What we would show here is, wow, look at this. There's some student that's getting not up as much sleep. Look at how long this whisker is. But that could be an outlier or just one piece of data. The median for the male students was 8.5. The IQR was distance between the two edges of the box, so 9 minus 7 would be 2. The median for the female students was 9. The IQR was highest minus lowest of the box, or the Q3 minus Q1, so 9.5 minus 8.5 would be 1. When we're dealing with these situations, the median and the IQR are used collectively to help notice things about the distributions. So the medians are pretty close. Half-hour difference, that's pretty close. The male students appear to have a little bit more variation because look how much wider the box is. Okay, the box is twice as wide, so there's a little bit more variation in the male students then versus the female students. That's kind of something that you would be looking at. Again, we're just looking at this for the first time. You want to focus on finding like the median on a box plot, finding the IQR of the box plot, and then comparing those things using the common language of the question. So this would be hours of sleep. So it appears that it's similar, but the male students have more variation in their hours of sleep than the female students. The next one is a lot harder because of what's given to you. We'll talk a little bit more about what this means in terms of why we're doing the MAD and the mean for this situation. It has to do with the fact that this is what's known as a dot plot as opposed to a box plot or box and whisker. For the box and whisker, they're actually much easier because all we can show you is the median and the IQR. If the data sets are symmetric, and by symmetric we mean they kind of start low, go high, and go back down. Now this is perfectly symmetric, like there's middle and there's 2 on each side, then 2 more, and then 1 more. It doesn't have to be perfectly symmetric, but that's what we're looking for, is some type of symmetry. If the data sets are symmetric, what you should be looking at is the mean and the MAD in order to compare them. For the male students, finding the mean, you'd have to add up all of these dots. So 59 for this 59 here, 60 plus 60 plus 61 plus 61, and you go through all the numbers, add them all up, and then divide by 15. That means the average height of the male students is 62 inches. The female students, if you add them up, 960 divided by 16, the average height is 60. So yes, the male students are slightly higher than the female students. The MAD, though, remember, MAD is distance, average distance away from the mean. So what I've done here is said that this is 59, that's 3 away from 62. There's 2 of these 60s, so 60 is 2 away, and there's 2 of them. 61, there's 2 of those numbers, they're 1 away, and I just keep going down the list. I find that to be 1.2. I do the same thing for the female students, and just to save time again, I just found it myself, and it's 1.25. What you would notice here is when we think about variation and measures of center, we would say, well, it appears that the male students are a little bit taller. Their average is 62, the females is 60, which makes sense. Okay, typically male students are a little bit taller than female students on a whole. Are there female students that are taller than some of the males? Of course, because there's some overlap in between these two groups. And they vary similarly, which means there's some shorter people and some taller people, because their MADs, their mean absolute deviations, are basically the same. Okay, they're close enough to each other. Now, what's close enough mean? Well, it kind of depends on the question, but these two are definitely close because 1.2 and 1.25 are very close to each other. That's the way we want to say if there's noticing anything in particular. We want to use the measures of variation, the measures of center. What we don't want to say is, well, they look about the same. Oh, well, we think the male students are taller. We want to have some data that backs that up in order to figure out those answers. Okay, your homework today is section 10.7. There's not very many questions. Number 3 is a question kind of like this, where we have to find things like find the mean, find the MAD, If it was a box plot, we do find the median, find the IQR. But you're going to have to write some things out. If it's a dot plot question like this, I'm going to expect that you're kind of showing me how you found these things, like found the MAD, found the mean. We're looking for these ideas for you to write them out. So make sure that you do that on questions if they show you to do that on number 3. Questions 10 through 14 are some review questions. You want to make sure you look back. It says what section those are from. You may need to look back in order to figure out how to deal with some of those questions. Really focus in on showing your work on number 3, though. That's what your teacher is going to be looking for. Have a good day, everyone.